Loops are everywhere in game development. You have your primary, secondary, and tertiary game loops, you've got your frame loops, you've got your physics loops, your loop-de-loops and hula hoops, and of course you have your programmatic loops, more appropriately known as control flow statements, which is what this video is all about. We're going to talk about what a control flow statement is, and then we're going to dive into some C# specific loops: the while loop, the do while loop, the for each loop, and the for loop, in that order. Then we're going to take a brief moment to talk about the break and continue keywords. So let's dive right in. So, what is a control flow statement? A control flow statement is a block of code that checks to see if some condition or set of conditions is true. If so, the block of code executes. This is a lot like the decision statements we discussed back in video 6 of this series. Where control flow statements differ is that if the condition is still true at the end of the block of the code, the execution moves back or loops to the top of the block and the instructions execute again. The reason loops are officially called control flow statements is that they literally interrupt the flow of your code. Your code won't move forward until the loop is completed. That means when using a loop, you have to be very careful to make sure that the test condition will eventually evaluate to false. If it doesn't, you'll have what's known as an infinite loop, a scenario where your loop never stops. If you're lucky, this will just crash Godot, but if you're unlucky, your code will become sentient and try to destroy everything you know and love. So, let's get started with the easiest loop to understand, the while loop. To write a while loop in your code, use the keyword while, followed by the condition or set of conditions you're testing in parentheses, and then your block of instructions. Nothing is going to help you understand loops better than seeing them in action, so let's look at some code. Here we have a scene that's nothing more than a centered label with a script on it, so let's see what the code does. Our script stores an array of strings that holds various animal names. In the _process method, we check to see if the UI accept action is pressed, which is enter or spacebar by default, and if it is, we call the run loop method, which has all of our juicy logic within. We start with an integer variable called num iterations, which will track the number of times our while loop runs. In C#, you can declare variables and methods with the var keyword as long as you're initializing them on declaration. Don't worry though, since C# is a compiled language, that means that unlike GDScript, you won't suffer any performance hits declaring and initializing variables this way. You cannot, however, use the var keyword to declare class member variables, even if you do initialize them. Next, we're making our own string variable simply called animal and initializing it with the value dog. Then our loop. Our test condition is whether or not our animal string variable is equal to horse, which it is not, so this loop will execute at least one time. Inside our loop, we're iterating num iterations, getting a random integer index between 0 and _animals.length -1, and we're assigning the appropriate animal from the _animals array to the animal variable we declared above our loop. Then we print the animal name to the output console. Once the loop ends, we're printing a little divider to the output console so we can see the results of each of our loops more easily, and then we're printing the number of times the loop looped to the label's text field. So basically, our loop is going to print random animals to the output console until it lands on horse. Then the loop will end and we'll see how many iterations it took to get to horse. Let's run our scene to see this in action. Okay, so here I already have the scene running with our output console extended a bit to make it easier to see. Now let me press the spacebar. Excellent. Well, the loop only had to iterate once there. It decided to land on horse immediately. Let's try again. Alright, that time the loop took 6 tries, a third time 3, and a fourth time 16. So this should give you a good idea of how while loops work. The primary use case for while loops is when you don't know how many times a loop needs to be run before getting some result you're looking for. A good gaming example of this would be a turn-based battle system. You'd have some condition that tracks whether the battle state is ongoing, and that would keep you in the loop that would then go step by step through the turns, following whatever logic you've programmed. Once a victory or loss condition is calculated, the loop will break. After all, you don't know how many turns the battle is going to be, you only know that the battle needs to continue until there is a victor. Which brings us to the kissing cousin of the while loop, the do while loop. A do-while loop, sometimes simply called a do loop, is the same as a while loop, except that it will always run its instructions at least one time. That's because the condition isn't checked at the start of the loop, it's checked at the end. The syntax for a do-while loop is the keyword do, all by its lonesome, followed by your block of code in curly braces. Immediately after the last curly brace, type the keyword while, followed by the condition to check, and then a semicolon. No examples for this guy because, again, it's just a while loop that's guaranteed to run at least once. This loop is even more appropriate for the turn-based battle system we just talked about, as you'll always want at least one turn. Next on the agenda, we have the foreach loop. Foreach loops loop over a collection and perform the exact same action on each item in the collection. Syntax is only slightly more complicated than a while loop. Type the keyword foreach, followed by parentheses and your code block underneath. In the parentheses, start by putting the data type that each item in the collection has, or if you're like me, just put var to make your life easier. Then type whatever you want your representation ID of each item in the collection to be. This is how you refer to the item in the collection you're currently considering in the loop. Often this is a single letter that corresponds to the first letter of the type or collection name that you're using. Now, normally you'd never want to make a nondescript variable name like this, but this representation ID variable will only exist inside your loop, so this makes your code a bit cleaner. Then you type the keyword in, followed by the collection you're looping over. Inside your loop, you can then use the representation ID you typed in the parentheses to act as the current item in the collection you're looping over. So in this example, S would correspond to underscore some collection 0 the first time it loops, and underscore some collection 1 the second time it loops, and so on and so forth. So let's look at some code. In this scene, I have 32 labels in a grid container, all loaded in the inspector. We're going to print some numbers to these labels using a foreach loop. Let's take a look at the code. Up top, we have the export field for our underscore labels array. I've already manually loaded all 32 of them in the scene. Next is a private integer underscore num, which will default to being initialized to 0. We're going to use this to make our scene a little bit more interesting. Then in the underscore process method, if we press the UIAccept action, we call the print numbers method. In print numbers, we declare a local integer variable and assign it the value of underscore num. Then we have our loop, where we're looping through every label in our underscore labels array in order. We print the value of print num to the label we're considering in the loop and increment it by 2. When the loop breaks, we're incrementing underscore num by 1. Before we show this in action, take a minute to step through this loop to see if you can figure out what the result is. Pause the video if necessary. Mentally working through loops is a good way to get comfortable with them. I'll be here when you get back. Okay, let's see if your assumption was accurate. If we run the scene and start pressing the button, you can see that we alternate between even and odd values while incrementing them each by 1 every time we press the button. Right on. If you're performing the same actions for each element in the collection you're looping over, a foreach loop is the way to go. One thing to keep in mind with foreach loops is that they won't run if there are 0 items in the collection. However, they will crash if the collection hasn't been initialized at all. So do a null check if you think the collection won't be initialized by the time it reaches the loop. However, sometimes you may need to get a bit more granular with collections being looped over, and the index of the item in the collection may be important. That's when you're going to want to use a for loop. For loops are a bit beefier in terms of syntax than the loops you've already seen, but aren't so bad once you get used to them. For loops are ideal for iterating over a range of values or collections where you need to know the index of the items in the collection. Like with other loops, you start with a keyword, in this case for, followed by parentheses and your code block underneath. Your parentheses are going to have a lot more in them than one test condition, however. The first thing you put in the parentheses is your iteration variable. Like the representation IDs in foreach loops, this is a special variable that only exists within your loop. This variable can be any number type, so int, float, or double, but remember, doubles aren't great for most games, so let's just say int and float. You'll declare and initialize this variable in the parentheses, followed by a semicolon. Immediately after the iteration variable declaration, you'll put your test condition, or the condition that will say whether or not the loop continues. After the condition statement, you'll add another semicolon, and that'll be followed up by your iteration variable increment, or what value you want to add to or subtract from your iteration variable each loop. Let's see one of these in action. Here, we're back on the same scene we used to demonstrate for each loops. And you know what sucks about this scene, like, a lot? Loading 32 separate variables into inspector fields. Seriously, Godot, Unity can load an entire collection via the inspector at a time. Get your crap together! Anyway, we can use a for loop to save ourselves some headaches here. Back in our for each loop code, we're going to get all of the label nodes via code. To start, we can get rid of the export property, as we're not going to need the underscore labels array exposed in the inspector anymore. Next, let's add an underscore ready method to do our initialization in. Now, we need to get the children of our grid container. There are a couple of things to note about this line of code. First, the getChildren method returns an array, and it's not a sleek, sexy C# array. Oh no, it's a doo-doo, poo-poo, gross Godot array that's being returned. And it returns everything as a node as opposed to the type we want, which is label, so we need to do some converting. Initialize the underscore labels array with a length equal to labelNodes.count. Yes, count. Godot arrays use count instead of length to represent the number of items in the array. Finally, we need to loop through all of the items in our underscore labels array and assign each index the corresponding label node's value as a label class. And that should do it. You can see we're using the iteration variable I as the index for both our sexy underscore label C# array as well as our icky label nodes Godot array. This ensures we're assigning the correct node to the correct label. Finally, we can wash our hands and be done with the dirty built-in Godot collections, save our script, and return to our scene. Build the project now to ensure there are no errors. You can see the labels array is no longer exposed in the inspector. Play the scene. Press the UI accept button a few times. And you'll see it's working just as before. This example shows where a for loop can save you a ton of headaches in a situation where the index of the items being looped over matter. However, for loops can just as easily loop over a set of values instead of a collection, and we'll take a closer look at that in our video on asynchronous methods, which will be coming up next in the basics series. Before I let you go, there are two keywords you can use in your loops that you may find useful: break and continue. The break keyword terminates your loop, ending it before the test condition evaluates to be false. You may find this keyword useful for things like when you're in a while loop or do while loop and you only want them to execute a set number of times, regardless of the test condition value. In the example you see on your screen, you'll notice that the output will only go up to 4 despite the loop checking for all values less than 10. That's because when I is equal to 5, we terminate the loop using the break keyword. The continue keyword is used to skip the remainder of the current loop iteration and move to the next iteration of the loop. Sometimes you want to loop through a set of items, do a set of actions to all of them, and then if an item is of a certain value or in a certain state, perform some additional actions. The continue keyword would allow you to break up those sets of instructions so that they can be performed in the same control flow statement. In the example you see on your screen, the loop continues if the iteration variable is even. That results in only odd numbers being printed to the output console. Those are loops in a nutshell. Apologies I don't have my normal wealth of examples, it's just that I think loops are a fairly easy concept to understand once you see them in action, and the only way to get comfortable with them is to use them yourself. Just remember, while loops are ideal for when you're not sure how long it'll take your loop to end. Do while loops are ideal for when you're not sure how long it'll take your loop to end, but you want it to execute at least one time. For each loops are ideal for looping over collections when you're performing the same action on each item, and you do not need to know the item's index. For loops are ideal for looping over a range of values, or collections in which the actions you're taking require you to know the index of the collection items. And stay away from those infinite loops if you have any people in your life that you care about.